All right, so Visual Studio. We want to step in and actually create a project, get going and doing some coding. If it's your first time running Visual Studio, you'll just go and you can either go to your start menu or it may be on your desktop and you'll just want to search for Visual Studio. If you're using one of the lab machines, Visual Studio 2012 is installed. I'm using Visual Studio 2013. I'm trying to work to entice the IT department to actually upgrade your machines to 2013. It's in negotiations. So, when you launch it for the first time, you will not see that box. But what you will see is something that will probably give you a prompt and say, what language would you like to program in? Or how would you like to set up your environment? That prompt, you will want to choose Visual C#. I've had people who did not follow those recommendations and they chose Visual Basic, and the first 2 or 3 weeks worth of assignments they submitted were in the wrong language. And they couldn't figure out why they wouldn't build. Because Visual Basic syntax is very different than C#. Oh, there it is. So you'll probably end up seeing something that looks not like that, like this when you first launch it. So make sure you pick Visual C#. It'll make the tutorials easier and it'll just make more sense as you're navigating things. Alright, so once you've gotten past that, you'll see a screen like this. This is kind of your start page. If you guys are familiar with working within like NetBeans or Eclipse, it's pretty close, especially NetBeans. So you come up to this screen, you have a list of new projects, and you have a list of recently opened projects on the left-hand side. In the center is a dynamic feed that's coming from Microsoft, and they're basically providing you with news and updates. And if you scroll further down, you actually get product videos, which are essentially 5 to 10 minute tutorials that'll walk you through new technologies, walk you through new products and old ones, and help provide you kind of a kickstart. I recommend looking at them if you've got some time, even just to take 5 or 10 minutes and say, oh, that sounds interesting. What's that? Click. It's a video. Put on your headphones, stare at the screen. Doesn't require a whole lot of work, but you might learn something. So, to start a new project, click New Project. By default, it'll bring you into this new project dialog. What you're seeing before you are what are termed project templates. We're underneath the Visual C# category, and these are the quote-unquote most common Visual C# projects that you would engage with. You have universal applications, Windows form applications, WPF applications, or Windows Presentation Foundation applications. WPF and XAML go together, so just kind of tuck that in the back of your head. Console applications, hub applications, ASP.NET web applications, class libraries, portable class libraries, and then further down you start to get into Windows Phone development. If you want to isolate yourself into a certain zone, in this case we're doing Windows development, then you can choose Windows Desktop and then you'll get a subset of those projects. And sometimes you'll get more projects that are more specific. Things like Windows services. Anybody here know what a Windows service is? Okay. If you go to your Start menu and you type in services, these are little programs that run in the background on your computer. They basically make the computer work. They turn on the moment your computer boots up before anyone ever logs into it. These are little applications that run and do tasks. If you're running a web browser on your computer or on your server, it runs as a service. Things that allow you to navigate and browse across the network to other computers, to allow computer-to-computer communication, that runs as a service. So if you ever wanted to build an application that just runs on the computer in the background, doesn't have a UI but does a certain task, you would want to build a service. You can build those in .NET. So we're going to start out real simple with just a command line console application. So this is week 2, part 1. I guess I should have actually explained the rest of that. Let me go back and do that. File, new project. Okay. So on this screen you have name, just like I did. Week 3, part 1 was the name I typed in. The line below that is the location. So that's where on that computer this project will be created and stored. By default, it points to your user profile / Visual Studio 2013 / projects. The name that you give this project will cause Visual Studio to create a folder to store that project in. So therefore, any pieces of your project from that point forward get stored in that folder. When you go to submit your project for a homework assignment or for a final project submission or a midterm, you will grab the contents of that folder, all the folders and files inside of it, zip them up, and then submit the zip file. There's also this option to create a solution. We'll talk about what a solution is in a moment. And then you can choose if you want to make your solution name different than your project. So once I put in my project name, I've chosen my console application template. I click OK. Visual Studio will then create that new project for me. Yours probably looks something more like this. Is that correct? You don't have the one on the side. Okay. On the left. Which is fine. You won't need it right now anyway. Obviously, I've customized mine a little bit for the way that I work. Okay, so what happens is that the new project is created. The only C# file in this project is opened. It's our program.cs. We looked at this briefly last week and we kind of just worked within this class. We didn't talk about the rest. If we look at our Solution Explorer, think of that as your file system browser or your Windows Explorer for this solution. It gives you just an isolated perspective of the solution, the projects in the solution, and then the files in that project. A solution is a file. So let's start at the top. Solution is a file. It is what's a word I can use? It is a file that tracks and manages kind of like a virtual file system. It basically contains nothing more than folders that don't actually exist and links to projects that are related to each other. So in this case, we have one project inside of our solution. We have our week 2 part 1 project inside of our week 2 part 1 solution. Every project is contained within a solution. So you have to always have a solution, and then you put one or more projects inside of that solution. Even if you go and you open a new project or an existing project without the solution file, Visual Studio will automatically create a new blank solution to put it inside of. And the idea is that anything inside of that solution, maybe it's a Windows Form application, maybe you have a Windows service component to your Windows application that runs in the background. Maybe you have a couple of class library or DLL files that have specific pieces of functionality that are part of that solution. And maybe there's also a web component where you have a web application that is kind of the sister to that desktop app. That's all part of that same solution and they have shared code. So when you go to build one, you're also building the others along the way. So you have this solution, a holistic application. And then the projects are those pieces broken out into individual compiling units. No, compiling unit, what does that mean? This project, when we compile it, it compiles into an executable, an exe, something that you can launch and runs in your command line. When we create a Windows form application, it's an executable. It's a .exe file. You run it, it creates a window on your screen. You can also compile class libraries. They compile into DLL files. Those DLL files do not run on their own. They are not executable. But what they are their class files or classes that are compiled together into a group. And those classes are then linked into an executable and have pieces of code that are used by another application. And we'll cover DLLs more in future weeks. But the idea is, what if I have this piece of code that, just what you were talking about with the mobile app, I have this piece of code, I created these classes. Well, I put these classes in my Windows application, my desktop app, then I put them on my iOS app, and then I put them in my Android app, and then I put them in my iPhone app, I put them in my web app. Because I want to reuse that code over again, right? I don't want to have to recode the same thing again. Well, what if I make a change to the class in application number 3 in the Android app that is relevant to the first two? Well, then I have to take those CS files, those class files, and copy them back to the other projects. And then it's just a round-robin effect of, did I copy those to the new project? Did I include them in the old project? You have to do all this file management. If you create what's called a class library and you put them in there, you create a DLL file that all of those projects can reference. So you make the code change in one place, you compile those changes, and then you set up a solution where that DLL is what's called a dependent. And then all of those projects reference that DLL. So every time you do a build, then that DLL gets copied out, and everybody always has the same version of that class. Like I said, we'll get into that in later weeks. But the idea here is you want to minimize the amount of redundant coding that you're doing. So just a general rule of thumb about programming is that you should not be duplicating code. If you feel like you've written this again, if you've written it before, you probably have, and you should stop coding it and figure out a way to isolate it and reuse it. Just a general rule. Alright, so within our project, we have properties, we have references, we have an app config, and then we have this class, program.cs. Every class has its own file. The class name and the file name should match. Unlike in Java, where they have to match, in .NET they don't have to match. But it gets really confusing when they don't. You can actually put multiple classes inside of the same file if you want to. Again, it doesn't hurt anything to do it, but it gets confusing when you do, because then you start to lose track of where your classes are. Every time you create a new class, it'll create a new .cs file, whatever your class name is, .cs, and they'll just get listed inside of that project. All the CS files that are contained underneath one project, they all get compiled together into either an executable or a DLL, depending on the project type. The executable or assembly that's generated will be the name of your project.exe by default. So when I build this, it'll turn into week2-part1.exe. The properties folder, if you want to think of it that way, contains one C# file, assembly info.cs. In here is a bunch of metadata about your application. Includes the title of the app, description, config, company, product, copyright, trademark, culture. If it's COM visible, which is the interop thing I was talking about before, a COM GUID, and then down at the bottom you have assembly version information. That's basically the build version that gets embedded into the app. So you can go and increment that by one automatically, or by whatever step you want. You can do 1.1.star, and every time you build, basically Visual Studio will auto-generate the last 2 digits for you, and it'll just work to increment them gradually. There's also third-party plugins that you can add, and it will automatically increment based off of a formula. Sometimes people like to do, they manage the major revisions, and then every build is like this date, dot, hours and minutes. So that way you can kind of keep a rough estimate of when was this build done? What version am I running based on when did I last modify it? References, this is that whole idea of assemblies and the .NET framework and all of those pieces. So Microsoft.C# is a DLL file, system is a DLL, system.core is a DLL, system.data is a DLL, system data set extensions is a DLL, system.xml is a DLL, system.link is a DLL. These are all part of the base class libraries. They all get included because that is the way that this project template is designed. Are they all needed? Are they all required? Will you use them all? The answer to all 3 is no, not really. Does it hurt to have them there? There's a little bit of memory overhead when they run because they will load in those additional DLLs into memory. So if you're not using them and you know you're not using them, it's always good to take them out. So, things to consider. Do they matter right now as you're learning it? No. If you want to add a reference to some other DLL, you would also do it here. You would right-click on References, choose Add Reference. It defaults to the solution, so if there were other projects in here that I wanted to pull in as a reference, I could do that. If I want to pull in another piece of the .NET framework, those are located under Assemblies. You can pull those in. If you really want to use one of those old-style COM components, you can do that too. There are some that are kind of fun. There's like a whole Internet Explorer component that allows you to basically browse a web page without actually having to click it. So if you wanted to build some sort of automated way of clicking through a website and filling out a form and doing things like that, you can do that using the IECOM component. There's other little ones in there that are kind of fun. A fair bit of Windows itself is still interfaceable through COM. They continue to add .NET pieces, but the COM is a good standby. And then if you just have a file you downloaded off the internet, you can browse to it and go pick it up. So last week we went through and we started building a student model. Actually, let me do this.